Any other question? Okay, let me share my screen. Am I audible?
Yes, Gaurav.
Yes.
Is my screen visible?
Yeah.
Okay, I'm doing on my server, but when your server, your problem get resolved, you can try by watching the recording. Just look at my screen only for now. So, have you studied about the sizing of NAND gate according to get unit inverter resistance, and have you studied about that? Do you have any idea how to size the NAND gate or any other gate? Okay, then sir will obviously teach it in the class. I'm just telling you that we are doing the sizing according to the to get the resistance same as a unit unit. So the our NMOS will be of two times of the unit size, and PMOS will also be two times of the unit size. So NMOS and PMOS both will be two times of the unit size. So in you know when you will study, you know the resistance of PMOS will be the 2R, and the resistance of NMOS we take as the R. So what will be the, if the size is two times, then the PMOS resistance will be R, and the NMOS resistance will be R by 2. At the worst case, if PMOS is on, you will see the resistance of R, and NMOS stack is on, then you will see the resistance as R by 2 plus R by 2 will R. So I sized according to them. So unit size is 0.135, and so two times I am taking as 0.27 and 0.27 all of the sizing. So let me proceed for the layout. Okay. So first let me generate it from the source, and I'm deleting the pins. Shift F, just repeated steps. So first and most important step, you have to on the DRD notifier. So go to option, DRD edit, and make sure it is on. So you know about the DRC on beforehand. So what will be the next step? This is our PMOS instance get created here, and NMOS instance will also get created here. So first, as you seen in the stick diagram also, we have to share the diffusion of the PMOS and NMOS here because it is layout Excel. So you are also saying the connection according to your schematic. Source is connected to VDD and drain is connected to output. And here also source is connected to VDD and drain is also connected to Vout. So let me rotate this transistor and select rotate horizontal. Now you can share these two diffusions and you get the common output. So for that you can drag and drop, or you can press A and click here, sorry, and then click here. It will automatically get aligned. Similar for NMOS. In the here Virtuoso, you can only drag to either horizontal way or vertical way, not in the diagonal way. So here it is GND, it is net 22, here V out. So I'm doing the alignment here also, pressing A. is not removing the contacts. Let me align with respect to poly also. I'm pressing A here, and you can press A here. It will get aligned with respect to poly also. Sorry. So now our transistors are aligned. So sometimes you can see the tool will optimize for this contact. It will remove the contact and then it will decrease the area for that. Then if the contact will remove, the poly will also shift slightly toward the left, and in that time the poly bending can occur. So it is your responsibility to make sure the poly bending will not occur. For that case, you can make the either layout from the scratch just by drawing the OD on yourself and then placing a poly over it, or you can do the you can, or if there is another step, you can go to the layout Excel from here. Sorry, layout L, and layout L will give the some sort of you will not do some sort of optimization, and it will not merge the contacts. Or you can also find any other steps to avoid the poly bending and make sure the contact will not get removed. So here the tool is not removing the contact, so I am continuing with that and drawing the poly. Either you can select here poly, press R, and it will get a draw, or you can also select the poly and press P. It will create a path. You can press here, and the poly path will. Sorry. It's not taken. So it by this you have connected to polys. Now I am taking the path to connect the output. So you have to connect it by metal one. I'm selecting the metal one draw, pressing the P. See, now the path will get created. You can just drag. Sorry, output is click here. It will get rotated, and you can again click here to rotate the path. And you can click and enter to get out of from the path. For the alignment, you can, as the previous, either you can drag and drop, or you can press A, click here, and click here. Select. If there is any doubt, let me know. Is it clear till now?
Yes.
So what will be the next step? We have to connect the VR to get the connection from poly and to provide the connection for VDD and ground. So let me create the VR. Create VR. I'm connecting for the poly first. So M1 PO VR. I'm rotating it. here, because the DRD notifier is on, you can say it is providing the DRC beforehand. Minimum spacing should be 1.0.12. If you turn off, then you will get a lots of DRC after making the layout. So I am pressing AVIA here. Now I am pressing the AVIA here also. You can optimize it according to your need, what you want. Now you have to provide the connection for VDD, so you have to create a VIA for M1 annual. I'm just putting it of the VDD SR. You have connected it with VDD. Now for this, I'm using path for this. You can press here. Press for rotation and here press and enter. Escape them. Is it okay? Now I'm providing the connection for the ground. Create. Is it clear? Save. Let me check the DRC first, or I haven't made the pins intentionally. So let us check the DRC. Or let me do some more. It's working. So let me create the pin beforehand only. So I'm creating the pin. I have to give the name same as our schematic, otherwise the LVS will show the error. So what was the name in small VDD and small GND, and type should also be the same as the schematic, otherwise the LVS will throw an error. So I'm creating the VDD pin. Go to create. First select the M1 pin and go create V pin. Create pin is available. Put VDD. Type input power. Changing the label 0.1. So not very big level. VDD. So So I'm removing the DRCs beforehand, some few DRCs. Let me flatten this via. So every instance which you generated or created directly, you have to flatten that. So hierarchy, flatten, select via, press OK. As you know, there should be either the minimum distance between the two anvils or they should be at the same voltage. So I'm putting the same voltage because I know the DRC of that. So you can remove the DRCs beforehand before checking them also. So I'm removing few DRCs beforehand. And the DRC of the minimum area of OD will also come. So to remove that, I have to increase this and then select this. See, until the minimum area DRC get resolved, you can increase the OD here also. And same in the bottom via, you have to increase the minimum area for OD here also. You can first select and flatten this. Yeah, press flatten. Let me know if there is any doubt. So I'm removing the DRC. So let us check the DRCs now. What kind of DRC will come? Save. Current DRC. DRC. So unresolved. So there are few DRCs. M1 area where it is. You can select on DRC and you can here press on this button send. Then it will show on where the DRC is. So as we know, the minimum area of metal should be something. It was written there. It should be 0.42. So I have to increase the minimum area for this via metal. So I'm going and flatten it, hierarchy, flatten. Or you can also add an extra metal from it by taking here. You can do this also. You can take an extra metal and draw above it. Hierarchy. So it is getting flattened. Now I'm increasing the area of this metal. So until the minimum area DRC 0.42 minimum area. So I'm increasing it. So this DRC is also resolved. I'm also resolving this DRC. Select hierarchy, flatten. So let us check. From DRC, you can try it at your own. So let us check now LVS. Do you think the LVS error will come or not? See here, there will be LVS errors. Yes, it is getting failed. Why it is getting failed? Because you can see here, it will be written here port in the layout there is one port, and in the source there are 5 ports, and rest everything is same. So I haven't connected any pin here for A, B, and ground. So let me create them also. So go to M1 pin, create pin, terminal name A, and it was of input type signal. Create here. So I'm not doing this. It is your. It is up to you how you can explore these things. So you will learn whatever you will draw and do. So try to remove all the DRCs and all the LVS. It is your responsibility for that. Let me show somewhere. Is there any doubt? So ground was I have taken as input output. So I'm selecting input output. So let me save it, and now you can see the LVS again, which was failed earlier. You can see here everything is the nets, whatever nets are present, instance, 4 instance, and 4 there, 2 NMOS, 2 PMOS, and ports, everything you can see here. Also click on incorrect nets, it is saying because of pin. You can explore these things. Go to the PNLVS. Yes. Okay. So incorrect. And layout 5 ports, and in the source there are 6 ports. Output is also missing, so it is again giving error on the LVS. So I'm again connecting the out pin. So go to a select pin, create pin, output. So now all the LVS errors has been resolved. So let me know if there is any doubt. See, this now LVS is correct. Is there any doubt?
No, it's clear.
So okay, you can try to achieve the minimum possible area when your server get accessible, and clean all the errors in the LVS and DRC clean for the tomorrow's lab.